This tungsten needle is the sharpest thing ever made. This needle has a point so fine it measures only 1 atom across. This is known as being atomically sharp and is the theoretical and practical limit of sharpness. For a tungsten needle, this is achieved through a controlled process that arranges the atoms into a perfect 1 atom point. It begins with a regular tungsten wire, which is then sharpened using a technique called electrochemical etching. The wire is submerged in a chemical solution and an electric current is applied, which gradually dissolves the metal until the tip is incredibly fine with a radius of a few nanometers. However, to achieve true atomic sharpness, an additional step is required using a process related to field ion microscopy. The sharpened needle is placed in an ultra-high vacuum chamber and cooled to a very low temperature. A powerful positive voltage is applied, creating a strong electrical field at the tip. This field is so intense it can pull individual atoms from the surface of the needle. By carefully controlling the voltage, scientists can evaporate atoms one by one, shaping the tip until it culminates in a single, perfectly pointed atom. But an atomically sharp object doesn't cut in the way we think. Normal blades, like kitchen knives and surgical scalpels, typically have their sharpness measured in nanometers, with a good quality kitchen knife having an edge radius around 250 nanometers and a surgical scalpel having an edge radius around 20 nanometers. When you apply force to a normal blade, the force is concentrated at the edge, creating immense pressure. As the blade moves, it ruptures cell membranes, tearing blood vessels and severing nerve endings. In contrast, a cut from an atomically sharp blade is more of a molecular separation than a tear. An atomically sharp blade, with its 1 atom tip, can fit between individual cells and even between the molecules that make up the cell walls. Instead of crushing, it unzips the tissue, parting the molecular bonds without a lot of collateral damage. Atomically sharp tips are primarily used in scientific instruments to see and manipulate the fundamental building blocks of matter. Their main use is in scanning probe microscopy, a group of techniques that allow scientists to image and interact with surfaces at the atomic level.